Hello everyone, I welcome you all in the Engineering Graphics YouTube channel. Friends, in this lecture, we are going to solve a problem based on cycloid. So you can see the definition of cycloid. Cycloid is defined as the locus traced out by a point on a circumference of a circle when rolls along a straight line without slipping. Now let us consider this is a circle. At the base of a circle, we consider a point P. This point P, this point P is rotating. This point P along the circumference of a circle is rotating simultaneously. The circle is moving along a straight line. At that time, the point P is rotating around a circumference. Same time, it is moving in the forward linear direction. Then the locus of this point is called as cycloid curve. Now you can see the problem statement for cycloid curve. Draw a cycloid of a rolling circle of diameter 50 mm. Now, for the cycloid curve, we required a circle of diameter 50 mm. So take a compass, measure 25 mm radius in your compass, 2.5 mm, draw a circle, divide the circle into 8 equal parts or 12 equal parts. Now here, we are dividing the circle into 8 equal parts. If you divide the circle into 12 equal parts, you will get a smooth curve. Now take a protractor and mark 45-degree angle on the both sides. 45. By using this process, you can divide the circle into 8 equal parts. Now here is the point P. This is 1, 2, 3, 4, 5, 6 and 7. Now from point P, draw a perimeter distance. So here diameter is 50 mm. So perimeter is equal to pi into 50. So here I will get 157 mm perimeter distance. So from P, mark a 157, 15.7 distance, 15.7 distance. This circular ring or circular plate rotating for 360 degree. Complete a rectangle of base is 157 and diameter height is given here. Now divide this base into 8 equal parts, same equal parts. So if you divide the circle into 12 equal parts, then divide this base is also 12 equal parts. But here we are dividing the circle into 8. So divide this base of a rectangle into 8 equal parts. So take approximate distance in a compass and divide this 30-degree angle line into 8 equal parts. 6, 7 and 8. 1, 2, 3, 4, 5, 6, 7, 8. Now join the end points and move the roller along the forward direction or draw the line parallel to the reference line. Now draw the vertical line. This is point P. 1, 2, 3, 4, 5, 6, 7 and 8. So the point P starts from here and end at a point number 8. Now from 7, 6, 5, 3 lines, draw the vertical lines. Draw the thin vertical lines. And after that, from point 1 and 7, draw the horizontal lines. Similarly, 2 and 6 points are same. 3 and 5 points are same. Now here, the circle, this is C1 center, C center. So here we will get a C1 center, the circular ring moving the forward direction. The center will change. C1, this is C2 center, C3, C4, C5, C6, C7 and C8. Now take a compass and cuts the arc on a horizontal line. Now you can take a radius distance in a compass. So take this radius in a compass. When the center C At the time point P is at the bottom of a circle. When the circle moving in the forward direction, 40-degree forward direction, from point P is moving from P to 1, at the time the position of P is here. So here we will get point P1. Now the circle moving at C2 center, at the time point is moving on a horizontal line to take a same radius, maintain the same radius. Now mark a point 3. This is P3, you can see 3, this is 3 horizontal line. 4 point you will get here directly. This is P4. This is P3. This is point P5. The 6 is horizontal. P6, you can see 6 line. 7, this is P7 and P8. Now, if you join all these points, this is 2, this is 3, this is 4. If you join all these points by using a smooth curve, we will get a cycloid curve. So this is a 180 curve, and next is 180. So this is a cycloid curve procedure. Try to solve this problem. Thank you for watching this video. Happy learning.